All right, so good morning, everyone. So we shall continue our discussion on if statements in this class, and we will also look at case switch statement, and we'll also see how loops are, like how while loop is being written, how for loop is being written in this class. Not only that, we will see how we can make use of GDB in this class. And all these things, instead of going through these slides, I would like to use code examples to explain how things work. And I recommend you to read the book to have a slightly more formal treatment to the subject. So here you can see there is a program factors1.c. We read the input and we want to check whether the prime numbers 2 and 3 are factors of the integer that is being entered. So on line 10, you see there is a conditional statement, there is an if statement. And so there are two Boolean expressions. The first expression is equality expression, which checks when you take the remainder of n with 2, if it is equal to 0, it can be true or false. And then we have the AND condition here, and then we have the AND condition here. So which connects it with the next Boolean expression, n% 3 equal to 0 or. So the way to, if you think about it, so this is, so you have the Boolean expression n% 2 equal to 0, and then here you have n% 3 equal to 0. If both of these are true, if both these left and right childs are true, then the outcome of this will be true. This is an AND, logical AND. So we are connecting these two Boolean operations with this AND operator. And so let's say if n contains both the factors 2 and 3, then the control will go to line 11, and so the statement n has factors 2 and 3 will be printed on the screen. And on line 13, so there is a new thing that is being introduced, this exclamation mark. So if this condition inside is true, then the negation of true is false. And if the condition inside is false, then the negation of it will be true. So line 13, the overall, this whole condition that is there, this will become true if 2 is a factor of n, and 3 is not a factor of n. If 3 is not a factor of n, the expression that is inside this, it will be evaluated to false. False means 0 in the parlance of C, and the negation of that is true. And both these things are true, and this statement at line 14 gets executed. Similarly, line 16, so this will check the first condition here will be true if 2 is not a factor of n, and the second condition will be true if 3 is a factor of n. So on and so forth. You can understand what it is from this discussion, whatever that is there. So in terms of precedence, then there is this idea of precedence that keeps coming up all the time. In terms of precedence, this double equal to, this equality relational operator, it will have a higher precedence. This will have a higher precedence than this AND. So what happens is this will be first executed, Not only that, this percent will have a higher precedence than equal to this equality operator. So because of that, first n% 2 will be executed. So I want to illustrate this idea of precedence through this uh, expression tree. So here we have the equal to operator, and here you have percent sign. Sorry, this is not coming out nicely. It is coming over the code, and here you have 0. Look at this expression tree. This expression tree tells you the precedence of the computations. Equal to, this is 0, this is percent, this is n, this is 3. So what happens is, if you look at this expression tree associated with what you have on line number 10, so the way this expression tree is computed is in a bottom-up fashion. And operators with the highest precedence, they occur at the lowest levels of the tree. So percent has the highest precedence. So you can see it is occurring lower in the expression tree. And this AND operator, it has Boolean AND, it has the, or logical AND, it has the lowest precedence. So it is occurring higher up in the tree. So let's say if n is equal to 8, then what happens is 8% 2 is equal to 0. So this 0 value, let's say if n is equal to 8, n is equal to 8. So 8% 2 is equal to 0. The value associated with this node is 0, and this 0 will go here, and 0 is equal to 0, so that it is a true. And in the context of C, true means 1, non-zero, and then this value is propagated up here. Similarly, n is equal to 8, 8% 3, it is equal to 1. So the value associated with this node is 1, and this 1 is propagated up here. 1 is equal to 0. This condition turns out to be false. False means 0. And then, so this value is again in turn, this false is sent up here. So true, true ANDed with false is false. So the value of this expression tree is false. Are you with me here? Do you understand this idea of expression tree? If you have any questions here, you can ask me, either on the chat, or you can enable your microphone and also ask.
Sir, can I ask a question?
Sure.
Sir, why did you take 8 and 8, sir? Isn't the number 88? Like, aren't we supposed to do 88% too? You took n
Oh,
equal to
it's
8.
no, no, it's not 8 and 8. It's not 8 and 8. I mean, my handwriting is pretty bad. It is and. It is an and symbol. It's not 88. That the
Oh,
root,
okay,
right?
sir. Yes, sir. At the bottom, you wrote n equal to 8.
No, no, it's not 8. There is no 8 at all. So this is, so how do we, yeah, so this is what I meant, okay? I'm sorry for my
Okay, sir.
handwriting, so that's what it is. But it is and symbol, double and,
Okay.
okay?
Okay, sir.
Yes. Chinmay has a question. He raised his hand. Chinmay?
Sir, you said that for in this case you said if from one side n modulo 2 would take a true value and n modulo 3 would take false. So it'll be 1 from one side and 0
No, no,
from the
n
other.
modulo 2 doesn't take true value. N
It
modulo 2 is
returns true.
0, and we are comparing 0 with 0, so it is equal to, so it becomes true.
So the end value after and is false, but that can happen in two separate cases. How does the computer distinguish?
What is it? I didn't understand.
The AND operator will return a false value in two separate cases, and you printed out four cases in the program. How will the computer be able to tell?
No, no, we are just thinking about the statement on line number 10 right now.
Okay, sir.
Chinmay, we are just thinking about, we are analyzing only statement 10 in the program. The expression that is there, in statement 10 is what we are analyzing, nothing else. We are not talking about line 13, line 16 or line 19.
Okay, sir.
Yeah, that's true. That's true, Pratyaksh. So, and we'll have least precedence. There are a couple of others who raised their hands. They can unmute themselves and ask the questions.
Sir, can you tell us how to choose the root of the expression tree?
See, it is actually simple. You just have to go to the, like when I think in your +1 and +2 or even earlier in algebra, the precedence operators, there is a precedence rules that are given, right? So let's say if it is 2 star 3 plus 4, star has a higher precedence than plus, then that means first uh, this multiplication will happen. Whatever the multiplication, the value of this multiplication, you add it to the next number. So this root naturally comes out as a result of the precedences that we give to different operators. So there is no magic. So given this whole expression here, what is the order in which you compute different sub-expressions that will naturally lead to a root? So you see this expression. So you look at the precedences of different operators. Percent has the highest precedence, so you have to compute n% 2 first, n% 3 again. So after that, the next precedence is for equal to operator. And after that, the next precedence is and operator. So that's all.
Yes, sir, understood, sir. Thank you, sir.
So there is one more catch here. Like if you see, let me. So you have this and, you have this and, there is a left subtree and there is a right subtree. This is a left subtree and this is a right subtree. And if the value of the left subtree, if this turns out to be false, then since it is an AND operation, you don't need to go and evaluate the right subtree. And this is what is called as short circuit evaluation, and which all C compilers will do. So yeah, so but on the contrary, if the left subtree is true, in order to know whether the value of the whole expression is true or false, you have to evaluate the right circuit, right subtree also. So please note this is an important thing. Later on, when you try to write some code which is bit complex, and where these expressions can have side effects, then it becomes a issue. So what you have to do is you have to remember, if the left subtree evaluates to false, then there is no need to evaluate the right subtree. On the contrary, if the left subtree evaluates to true, you have to go and evaluate the right subtree. I see a couple of hands being raised, so you can ask the question.
Sir, am I audible?
Yes, Jatin.
Sir, if in the right hand side of the and we had used something like n plus plus, but the left hand side was false, so would the compiler not have carried out the n plus plus on the right side?
Good question. So thanks for asking that question, Jatin. So I'm clearing all my stuff here. Let's come back. So the question that Jatin asked is this: n% 2 and n plus plus equal to whatever, some 4, and you do something. All right. So here, so don't look at the logic of the code. I wrote some arbitrary statement. So here it's an important, this is an important example, because what you have here, this left, the right subtree here, it has a side effect. So the right subtree here, it has a side effect. So the side effect is that the memory associated with variable n is going to be updated. It has side effect. So while there is a comparison happening, it has a side effect. So, so let's say if the left subtree, or in this case here, if this is false, okay, if this is if this is true, then you go ahead and execute this right subtree. But on the contrary, if this is false, then you don't go to the right subtree and execute it. And because of that, the side effect wouldn't get into, will not be, that n will not be incremented. And if the logic of the program that is here, after if statement depends upon the value of n being incremented, then you may get into trouble, because you are hoping that, n will be incremented in line 13, but it is not the case, because the first or the left sub expression tree, it evaluated to false. So the compiler didn't, the execution didn't go and evaluated the right subtree. And because of that, n is not incremented. But here on line 16, you are expecting that n is incremented, then there will be a problem in your code.
So you're saying that n, like for after line 13, n will become the updated value as to n plus plus, and that will be put in as the argument.
That's true. That's true. That's true. In fact, I also want to take this opportunity to highlight the fact, since it is n plus plus, the previous value of n will be used in the comparison operation, and then n will be incremented.
Excuse me, sir.
Yes.
Sir, but in this case, how do we know if the left tree is evaluated first or the right tree is evaluated first?
No, the convention is left tree is always evaluated first.
So, sir, then n plus plus or n should not make any difference, right?
No. So your code, it makes a difference, because if your logic depends on incrementing n, okay, like within the if statement or after the if statement, if the logic depends on incrementing the n, then it becomes an issue, especially after the if statement. If you assume on line number 16, you have written a code, okay, you have written a code. So code assumes that n is incremented by 1 because of the expression on n is incremented by 1 because of the n plus plus increment operator on line 13. You cannot assume this, because there is no guarantee that n plus plus will be executed. It depends upon whether the left sub expression tree, whether it evaluates to true or false. If it evaluates to false, then the increment operator wouldn't be executed, and on line 17 you get into trouble. And on the contrary, if it is true, then increment operator would be executed, and so then on line 17 it is all right.
Okay, sir.
Expression tree for line 13. Let's try, why not? So here, I hope this is better, and equal to, and this is n, sorry. Yeah, so here this is 0, this is percent, this is n, this is 2, and here equal to 4, and so yeah, so here it is a bit tricky. The way I would say is I want to make something explicit. So because of that, this is n++, right? Yeah, so let me kind of drawing an accurate expression tree here is painful, but let me just make it simple and try to explain it using words. So the left subtree is easy for you to understand, but the right subtree is a bit painful. So let's say if n is equal to 13, then what happens is the value that is returned here will be, let me use different value because there is no relationship between 13 and the code being on line 13. Let's say n is equal to 23. So the value that is being returned up here is 23. There are two things that happen. That is the value 23 goes up. Okay, the value 23 goes up. And the second thing that happens is the memory location associated with n, it will be updated with value 24. But the important, and then 23 is compared with 4 and it is turns out to be false. So here the value that goes up the root is false. Important idea is, so if n is equal to, in this particular case, if n is equal to 23, so this is n is equal to 23, n is equal to 23, 23% 1 is equal to 1, and 1 will go here, 1 equal to 0 is false, and since this is equal to false, the right sub-expression tree will not be executed at all.
Excuse me, sir. So can I ask a question about this only?
Sure.
Sir, so if we exchange the LHS and RHS of the AND operation here, making the n++ equal to 4 come first, so that would be evaluated first, right, sir?
That's true. That's true.
So, so then the n that goes to the other side,
Hmm.
so will it be 23 modulo 2 or 24 modulo 2?
It will be 24.
Okay, sir.
Yeah.
Thank you, sir.
Okay, good discussion. I think all the ideas that are necessary are being covered here. Are you all with me here so far in today's lecture? Great. So now let's execute this code. So there is a question: when you performed an expression in the printf statement, it evaluated from left to right. So shouldn't the value get updated for the left tree too? There is I want all of you to remember, printf statement is a function call, and what you are seeing is pure expressions. So there is no analogy between printf statement, which is a function call, with what we have here. So here earlier, just want to, since there is just want to make it clear. So you have printf and then %d, %d, and there is some expression E1, some expression E2. So here, so this is completely different. There is no precedence at all here between E1 and E2. And on the top of that, we have seen in the last class, each compiler is having its own convention. Some compilers are evaluating these expressions from right to left, and some are evaluating them from left to right. So there is no standard for it. So the idea of precedence does not come at all in the context of printf statement. But whereas if you see, this whole thing is one expression, and this whole thing is one expression, and there is this idea of precedence, number one, and the second idea is the idea of short circuit evaluation. That is, if the left sub-expression tree is false, then you don't need to go ahead and do any more computation to know whether that expression is, whether the whole expression is true or false. If you use ++n, the value will get updated in the same line. I guess so. Yeah, if you use plus plus n, the value will get updated in the same line. Yes, Sushi. I think we should get going. So more ideas to see. So let's compile this code. So Krishna Praneeth has this question which is worth mentioning. So here, which is, so if you have an expression, even or, the or operator is two vertical bars, you will have an example. If even or with E2, if this is true, then this will not be evaluated. E2 will not be evaluated. But on the contrary, if E1 is false, then E2 will be evaluated. Okay, are you with me on this one? This is an important thing to mention, and it's an appropriate context to mention also.
Sir, can you just explain it again?
So we are computing the OR of two expressions. So here, for example, instead of and, so if you put an OR, maybe I have one example here. Yeah, so I will explain it in a while. Let's take an example. Let's go ahead and I will explain it in a bit while. So let's compile this code and see. GCC factors1.c. So 32, so n2 is a factor of 32, but not 3. But if you take 6, n has factors 2 and 3. And if you take 7, then n has neither factors 2 and 3. So it's all expected, nothing surprising. So now let's go to this code. This is the question that's being asked. So here, in this particular example, so if you draw the expression tree here, so there is an OR operator here, there is an OR operator here, and then we have equal to percent n 2 and then 0 equal to percent n. So here, if the left subtree evaluates to true, then we don't go ahead, we don't evaluate the right subtree. Like for example, if n is equal to 6, okay, let me use a different color to, so n is equal to 6, then the value associated with n% 2 is 0. 0 compared with 0, it is equal to true. True is some non-zero value, 1. And so this gets propagated here, so we don't need to, the compiler or the code that is being generated by the compiler doesn't go and evaluate this subtree, because we already know that the expression value is true. Are you with me here? Pallav, you asked this question, does it make sense for you?
Yes, sir. Thank you.
Let's compile this code and see GCC factors2.c. So n has either 2 or 3 as factors. Okay, so let's, so but on the contrary, if it is 34, 35, let's say 35, so it's not, n doesn't contain 2 or 3 as a factor, and that gets printed. Yeah. So now let's look at this code. So factors3.c. Yeah. This is just to illustrate that as we have the equal to operator, we have not equal to operator also. So here we are reading n and f, and we take n% f, and if n% f is not equal to 0, then f is not a factor of n, and that's all. It's very simple code. Kush, I think it is from left to right. It's all. So this and double and. So the question is, I think, if we have something like E1 and E2 and, so we kind of do the evaluation from left to right. This is left associate. So this is also a simple piece of code. Let's run it once and see what happens. GCC. But all the important ideas are already being covered. So then 32 is, so F is not a factor of N. So there are few questions on precedences between different operators, etc. on the chat box I can see. My suggestion is you should take a look at the textbook, no, because I also just have to check the textbook and see, hey, this operator has a higher precedence than the other operator. So your questions are valid on precedences, but all I want you to understand is there is this idea of precedence and associativity. And if you have a doubt, you should go. So some precedences and and associativity properties we have seen in the class, but it is not a complete discussion. A complete discussion on it would be boring for you also. So I will skip that. You should look at the textbook. The textbook completely lists out the precedence and associativity properties. Is it all right? Now let's take a look at this code, grades.c. So we have these macros, 4 macros, that is out of 100, if you get greater than 80, you get A grade, greater than 70, B grade, greater than 50, C grade, greater than D40. So we are entering, we are asking the student to enter, we prompt for the student marks. We read the marks into the variable marks, and we check if marks is greater than this, then we say the grade is A. You can see the if part, and then this whole if statement that is there here, it is in the else part. And if marks is greater than this particular cutoff, we say grade is equal to B, so on and so forth. And if you recall the discussion from the last class, so when there is an if statement with no explicit blocking, that is using this, if you don't block them, explicitly mention the blocking, we match the if to the closest, we match the if to the closest, we match the else to the closest if. Match else to the closest if. So if you look at the cells, the closest if to the cells is this if, and the closest if to this is the cells. This for this cells it is this, and for this is. But this is a bad way of coding, because a much cleaner way of doing it is to make this this association explicit by, for example, putting a something like this. If you do this, this is much cleaner way of doing it. Then we know for sure that this whole thing that is present here, it is part of the else. So this is the way to do it. However, sometimes you don't want this for some reasons, because when there are deeply nested loops, like deeply nested if statements, then putting lots of these flower brackets, it looks a bit ugly. So if you format this thing, then you will see it will turn out to be like this. And this is slightly more understandable. That is, if this is true, then like grade is equal to A. This is a kind of standard template that you can use, and this template works. Are you all with me on this discussion on this if statement? So let's compile this code and see what's so marks is 32, student gets an F grade, sorry. Let him give 85 marks, he get an A grade. Good. So maybe if he gets 65, it's a C grade. If he gets 72, it's a B grade, so on and so forth. I want you to remember this code template. Like when you have multiple deeply nested if statements, if you write it like this, it becomes clear. Great. So now look at what is called as a switch statement. So here in this example, so here we take the marks of the student, and from line 16 to line 25, the if statements from line 16 to line 25, it gives the grade of the student, it assigns the grade to the student. And then we also want to give some remarks. So we have this switch statement which says a switch grade, and there are multiple cases. So if grade is equal to A, then control jumps, then the control flow jumps to the statement on line 31. And so the control keeps going like this. And once it sees the break statement, then control will go to the end of the switch statement. If there is no break statement, then control will fall through to, if there is no break statement, then the control will fall through to line number 35, and whatever that is there on line number 35 also gets printed. And when it sees the break on line number 36, it will stop. And if this break statement is not there, then the control will continue like this, so on and so forth. So let's compile this code. So the important thing here is that in the case statement, the value here, it has to be, you cannot use an arbitrary expression here. You have to use a constant here. In the case, you have to use a constant. You cannot say case x plus 1. It's not possible. It has to be a constant. No expression allowed there. No expression allowed. But here expressions are allowed. Any expression can be used here. Expressions are allowed. And you have to look at this, and if grade doesn't match any of these things, then there will be a default option, and the control will go to the default option. And so an illegal grade, whatever the statement that is here, that will be executed, and it will be printed. Okay, let's compile this code. GCC. Like for example, if it is 32, then yeah, the student gets an F grade and he goes to fail. And we also print that the student is will fail in the course. So now I want to use GDB and see how this thing kind of works. Yeah. You can see the code, Tanay. Let me actually run through this code through an example, so that through GCC minus G. So if you want to use GDB, so I want you guys to pay attention here, because we are introducing the most important tool in this course, and not only in this course, for the rest of your career as a programmer or a computer scientist. That is how to use these debuggers. So you compile this code. In order to use the debugger, you have to use the minus G option. So you see GCC minus G, switch1.c. Now we use GDB a.out. Okay. And so usually, so we use a kind of a user interface for GDB, which makes it easy to debug the code. that is called as a TUI interface. So TUI enable, and I am putting what is called as a breakpoint at main. Main is the function. I'm putting a breakpoint, B space main. I'm putting a breakpoint here. So there is a breakpoint being set. Now I'm telling GDB to run the program. So GDB will start running the program, and it will stop executing the code at the breakpoint. Right now the breakpoint is on line 8, that is at the beginning of the main function. So it starts executing at the beginning of the main function. It stops executing and transfers control back to us. So I'm saying run. Great. So you can see that on line 9, which is the first line of code of main, so there's a breakpoint. So because of that, we have stopped, GDB stopped executing the program on line 9. So now what we want to do is we use this command called as next to tell the GDB execute the next command. The next statement is there on line 13. Show what, Vivek?
Sir, how did we get into this interface?
Sorry?
Sir, how did we get into this interface? Sir, my internet connection just died, so I couldn't understand. We enable.
Okay, so let me quit and come back again. The first thing to use GDB is you have to compile your code using -g option. -g switch1.c. First is to, and then in order to invoke GDB, so you say GDB, you want to debug the file, you want to debug the executable that is present in a.out. Shashwat has this question. Shashwat, please go ahead.
Am I audible, sir?
Yes, yes.
So the GCC -G flag is compiling, as I understand it, is compiling the code in a particular way, allowing us to debug it later. But sir, is this safe for production ready code? Or will I have to recompile it without the -G flag if I am to say publish?
Yeah. So you don't use -G option for production code. This is only during the development phase. We usually use -G option, not during the actual release of the final executable to the end customer.
Understood, sir. Thank you.
So you say GDB a.out because we are telling GDB that we want to debug the executable a.out. And what we want to do is, let's say the simplest way is if you just say run. Okay, if you are telling GDB to run the program, and the program is running and it is asking enter student marks. I said 32, and it's all done. The program got executed. We are out of the program. It printed the student grade and we are out. So you can run the program again, and so let's say the student marks is 65, and so the student grade is printed and we are out of it. So we can run the program multiple times. So Kishore has this question, what is inferior 1? So I don't know, Kishore, so we will look into those other information maybe later. But you can see one thing though, that this process 12740, when you run a program, I told you, it becomes a process. So 12740 is the process that is associated with that program execution, PID of the process. So see, one important thing I want you to mention here, there will be many informations. GDB is a very complex tool and you can do many things, and it provides a lot of information. We will not be able to look at everything in one session, and you will get lost also. And so just follow what I am pointing to. Don't look for anything else. Okay, they are all valid questions. If you have no good valid questions, Unless they are basic in nature, I will take those questions in a different session. There is one good question. Is there any disadvantage in using GDB that is there in Visual Studio Code editor? There is no disadvantage. We can use it, but sometimes you feel I feel using this GDB is much better than the Visual Studio Code GDB. Although the underlying tool is the same, there are some things which I would like to do which Visual Studio Code is not permitting. Maybe I think it's possible, but I didn't figure out a way to do it. But let's learn this. It's very good to learn to use the debugger in this particular way. This is like the bare bones debugger. If you learn how to use this, then you will learn how to use GDB in any other IDE. Okay, so that is the this. Okay, so now let's see. So this, it's a TUI. It makes debugging your program easy. That's all. So I said TUI enable. So don't try to remember the commands. You can watch this video again. Just follow what I am showing. So don't try to remember the commands. You can watch this video. And I already posted a GDB cheat sheet on the course website. So you can check that cheat sheet also. Now I am setting a breakpoint on main. That is the beginning of the function break main. And you can see breakpoint 1 at some particular address in file switch1.c line 9. So if you go line 9 here, this is where the breakpoint is set. So now I am running the program. I say run the program. So now since the breakpoint is set on line 9, so control stopped at line 9. The program execution doesn't go further. But now I give the command next. When I give the command next, the next line gets executed. Then, so we go to line 13. So now line 13 supposed to be executed. Let's see. Yeah. So you see enter student marks. We enter 32. Let's say. And for some, yeah. And then you say next. So one thing you can see now, so on line 18, the marks is equal to 32. On line 18, you can see marks, that condition is false. So I don't need to press next again. If I keep pressing enter, the previous command, what is next, it gets executed. So I press enter. So marks is not even greater than C underscore cutoff. And then marks is not even greater than D underscore cutoff. So finally, it goes to line 25. On line 25, so grade is set equal to F. And then if you can see print student grade. So there is one interesting thing at this point on line 27, student grade should have been printed onto the screen. It is not printed yet. There is a reason for it because the output is buffered in the output buffer, and the GDB, it's not at flushing the output buffer. Because of that, on line 27, although printf is executed, it's not yet printed on the screen. But go to line 29. When you see line 29, so switch grade is equal to F. So what happens is control is transferring to line 44 and printf is failing is done. And then you press an enter. And you can see on line 44, after printf on line 44, it is getting printed on the screen. The reason is whenever /n is there, whatever that is there in the buffer, it gets flushed out. Okay. So because of that, after line 44, whatever that is being printed and it is there on the output buffer is being printed on the screen. And then you press, do Control L, you do next, you are out of the program. I am pressing enter. How to make the debugger flush out the buffer every printf statement? So I think if you use maybe flush, I didn't try it out. Let's see if this helps. Flush means flush the output buffer. Let's compile this program again and see what happens. So there are many questions. I want you to focus, just you will get answers to all your questions, but I want you to focus on main things that I'm showing you. Okay. So GCC, so what is that file? Switch1.c. Okay, -j I have to use. Clear. Now I'm saying GDB a.out, and I'm putting a breakpoint on main. I'm saying TUI enable. You can use breakpoint printf also, Sushil, it is possible. Yeah. So I'm saying run. So next. And actually you can see after line 13 also, now line 13 is executed. This enter student marks is there in the output buffer. So it's not being printed. So it could be a bit confusing for you when you run it, use GDB for the first time. Hey, printf statement is executed, but enter student marks is not coming onto the screen. What should I do? So it kind of comes when after the scanf gets invoked. You know, after the scanf gets invoked, it comes. So maybe let's do one thing. Let's try to keep an flush after this also to see. Yeah. So now after flush is there, no, whatever, see what happens is when you do printf, the whatever the string that is being printed, it is kind of buffered in some output buffer, and it gets that buffer gets cleared if the buffer is full, or if there is a slash n character in the that is being pushed into the output buffer, or if we use flush explicitly. So I don't want you to get too much bogged down about this, but since there is a context I am telling you, so the output gets buffered, it gets flushed out if the buffer is full under these conditions, if the output buffer is full. Second is if slash n character is there, then also I think it gets flushed. I'm guessing it because I know, and then if you can use explicitly a flush std out. All right. So now student marks. Yeah. So this is not coming out quite clean, but anyway, let's see. So it's a 32. So you can say I'm just pressing enter. And when I press enter, then that means, so whatever the command that is there before, that is next gets executed. So grade f, and then this printf will be there. And since now here we are doing an flush out, it is getting printed on the screen. And you go to line 46, and the break statement will take us out of this switch statement. So without that 2e, maybe you can even try to do this. So, so now if you don't use this TUI interface, this is what you get. You go to line 9 and then I say next. So the next now will tell that, that the next statement that is going to be executed is statement on line number 13 and it's a printf statement. So this is using without using TUI interface. And then I press an enter, flush out std out is there. So enter student marks, it gets printed. And so now the next statement to be executed is no, statement 15, that is a scanf statement. And when I press enter, it is prompting for the input. Let's say the marks are 98. Okay. And now the control will go to line 17. On line 17, we check what is marks. We can see what is there in the marks by using the statement p marks. You can see the variable marks is now assigned value 98. Okay. And you press next. So marks is 98 is greater than a cutoff. So the statement on line 18, this is line 18 statement. This is line 18 statement. It gets executed, and yeah, the student grade is printed, so on and so forth. That's all. That is how you can use GDB. How many of you kind of understood what's going on in the GDB? You can see that there are some commands. So you just have to use those commands, learn how to use the commands. And so that is all. And so using GDB is a very, very powerful tool. So some students kind of got it and some students kind of understood it. So this is just a tool. If you just use it a couple of times, you will understand it. Maybe in a tutorial session, the TAs will help you go through, help you, use GDB. And also there's a GDB tutorial also, not tutorial, a cheat sheet is being posted on the course Moodle. You can use that also. So those of you who are a bit lost on using GDB, don't get overwhelmed. It's very, very simple tool to use. It just takes an hour of practice. So if you didn't quite get how to use GDB in this session, it is perfectly all right, because if you do it along with me, you will know. But so in the tutorial session, the TS will help you learn how to use GDB. So don't get overwhelmed about if you didn't quite understood how GDB is used. And so let's, one interesting thing I want to show again. Here, this work. Okay. So if I am running this program again, so this is the switch code which Tanay wants to see. So this is, how many of you are with me on switch statement? At least I guess we kind of got lost in the GDB when we started with switch. Okay, good. So yeah, so let me use, so let's see again how to use this GDB again. So now we started running the program. Please pay attention right now. So let me do one final pass on this GDB before I conclude this lecture. But the TS will do it again. Those of you who are a bit lost, please pay attention. Okay. So here, this is the program. This program has three parts. In the first part, you read the student marks. In the second part, you assign grade to the student. In the third part, you kind of print a message saying whether excellent, good, average, poor, whatever it is. So what are we doing? We are starting GCC minus G. And what is the code? Switch one, sorry. This is switch1.c. You have to use the -g option, which is the debug option. The next thing that we are doing is, so the executable that we would like to debug, we want to supply it to GDB. So the command that we execute is GDB a.out, because a.out is the file that we would like to, is the executable that we would like to debug. We'll say GDB a.out. And so while debugging the program, we want to put breakpoints at different places to trace how the code is flowing. In a small program like this, it's not a big deal, but when the code becomes complex, you want to exactly see how the control flow is happening in the program. So you have to set breakpoints appropriately and use those breakpoints to navigate through your code. So here in this simple program where we are trying to see, what is happening from the beginning of the code, we are setting the breakpoint at the beginning of the main function. So we say breakpoint 1. So we say break main. So when we say break main, you can see the message that one breakpoint is set up, and it is on line 9 of the, so this is line 9. So this is line 9 of the file. So now you have set the breakpoint. Now you say you start running the program. So when you start running the program, so what happened is on line 9 there is a breakpoint. So the control stop will there, and you can see at the breakpoint the GDB will print the next line or no, that needs to be executed. So in order to carry out the execution of the next line, so you just give the command next. So I say next, you tell GDB next. So GDB has executed. There will be some initialization code between line 9 and line 13. That code is executed, and the next statement that needs to be executed is line 13, and that's what GDB is showing. That on the next statement that the GDB is up for execution is the statement printf on line 13. So what do? You press next. When you press next, the printf got executed, but it is not printed on the screen because whatever that enter student marks, it got buffered in the output buffer. It's not yet printed on the screen. If there is /n, then the output will be printed, or if the buffer is full, the output will be printed. But neither of these conditions are satisfied. So because of that, so what happened is on line 13, even though the printf statement got executed, the statement is not printed on the string is not printed on the screen. So we want to explicitly flush out the output buffer. And the way we are explicitly flushing out the output buffer is by making use of this fflush stdout statement, which tells flush out the output buffer, standard output buffer. And when we say next, so since the output buffer got flushed out, so this whole thing, enter student marks followed by space, got printed. After that GDB printed this particular output 15 followed by scanf. What this means is the GDB is up for executing the statement 15, which turns out to be a scanf statement. So on this whole line here, you have to see this whole line into two parts. The first part is the output of the fflush of the program that you are executing, and that output is being interleaved with the output of the GDB program also. GDB is saying, you know what, so the next statement I want to execute is statement 15, that is scanf. That's what this means. Are you with me here on how to parse this whole line? Yeah. So there is no /n because of that printf, the string within that printf is not automatically flushed out. Can we set breakpoints on specific lines rather than on functions? Exactly. Yeah, that's true. Yeah, fflush is like a force display. Yes, Tanay. Yeah, we can set breakpoints on specific lines. You can set breakpoints on function names. All those things are possible. So now what is the next statement that needs to be executed? That is scanf statement. So I'm giving this command next. So nothing is coming, but that is because scanf is prompting, scanf statement is being executed and scanf is prompting for an input. So let's say the student got 95 marks. So I entered 95. Great. So now marks got entered into variable, that 95 got entered into marks. So if you go print marks, pre-marks, you will see that the value that is present in the variable marks is 95. Are you all with me so far till this point? So there is one question: is it possible to change the value of a variable within GDB? It is possible. Like for example, I think if I say set marks is equal to 75, then what happens is if I check the value of marks, it becomes 75. And this feature to change the value of a variable within GDB, it will be of so much useful when you are debugging complex programs. So please remember this. If you want to print, you say, so actually P is a shortcut for print, so it is print marks. Yeah, no need for repeated /a.outs, nothing. And if you want to set marks to, now marks, you know, it is 75, but let's set marks back to 95. Okay, so print marks. So now marks is 95. So shall we go ahead and see, execute the next statement? This is next. You can see if marks is equal to 95, this condition is true. Because of that, you go to line 18. And that's what is happening here. So here, if you see this, the next statement, it is supposed to execute before is marks greater than or equal to a underscore cutoff. It turns out to be true. So you go to line 18. So you go to line 18 here. Okay, so and then now let's see, before line 18 gets executed, let's see what is present in grade. So you can see grade contains some arbitrary value before line 18 gets executed. So now after line 18 gets executed, so let's see what is present in grade. You can see the value that is present in grade is A, and its ASCII value is 65 that is being displayed. Is there a command for going to a previous command? It's very difficult, Tana. It's not. Yeah, so next we'll go to the next in the control flow. That's true. So now printf statement will be executed. So now printf statement is executed. After printf statement gets executed, this is printf statement is line 28. It got executed, but nothing is printed on the screen because it is buffered. So see, enter whatever the previous command, when you press enter, whatever the previous command, it gets executed. So like for example, P grade, you know, so if I press enter, the previous command gets executed. So, but now we don't want previous command, we want to go to the next statement, which is on line 29. So this is what line 29 we want. So line 29, you can see this is line 29 is flush std out. So I will say next. So now after flush std out, the output that got printed on line 28, it got flushed out. And you can see the way to parse this sentence is this. This student grade A followed by comma is printed for, and then this space. This whole thing is output of the program. And after the GDB printed this, that the next statement it wants to execute is present on line 31, which is switch grade. Are you with me here? That how to parse this sentence? Because this in this output, the student grade A, comma, followed by space is coming from this printf statement. Followed by that, the output of GDB got interspersed or interleaved. GDB is saying that the next statement it wants to execute is the switch statement from line 31. So on line 31, so what is grade? So grade is A grade. So the control should go to line 33. So now, yeah, so line 33 and 34 is that printf excellent /n. And so now you can see you don't require a flush after this printf because there is a /n here. When /n is there, when printf statement encounters /n, everything that is there in the output buffer, it gets flushed out. And in this particular case, the only thing that is there in the output buffer is excellent that gets flushed out onto the screen. So it got printed onto the screen. And the next statement to execute is the one that is on line 35, which is the break statement. And after the break statement is executed, you come out of the switch and you come to line 52, which is the end of the program. That's it. Are you all with me on this example? Can I see how many of you are with me on this GDB example last? Good, good. So it's not very difficult. So those of you who are a bit lost, I want to reassure you. So you may have a little bit difficulty in getting this virtually, but this is absolutely easy. All you need is just 1 hour of practice. That's all. So unfortunately for you, so your mind is split into 2 streams of thought. So one stream of thought is on how GDB is working. The other stream of thought is how this output buffer printf, so how this is going to output buffer and why this flush. So I see that there is a, so for most students, these two things are going in parallel in your mind. One is absorbing GDB. The other is you are stuck with printf. My take on this printf is don't pay attention to it. Okay, so printf is designed in such a way in order to enhance performance or things like that. I think so. I exactly am not sure about the reasons why it is being done in that fashion. So don't worry about printf thing that much. It doesn't affect you. In 99.99% of the cases, it doesn't affect you. So don't worry about it so much. But I want you to be aware of this because sometime down the lane, if you get into trouble, like printf buffers the output and either the output will be flushed either explicitly using a flush, or it may be flushed after the output buffer is full, or it may be flushed when a /n character is seen in the output. If you are aware of these things at one level, then if you encounter such a problematic scenario in practice, then you can dig deeper and try to find a solution to the particular problem that you are facing. But otherwise, don't worry so much about printf. Okay, what is happening on the output buffering part. And on the second side, GDB, you see it's a tool and it's a very, very powerful tool. As you can see in the middle of the program, you can change the value of the variable. And you can do many fantastic things using GDB. But you don't learn GDB in one day, you just learn it across few days. And within the semester, by the end of the semester, you'll all become master GDB users. Yeah, but within 1 hour, you know enough GDB to do many tasks. And one thing at this point I would like to highlight is many times when people try to debug, later on you will see the way people debug programs is by inserting multiple printf statements in your program. That is a very rudimentary way of debugging programs. Like for example, you are not sure whether the marks that you are being read is let's say you entered some marks and you are getting some grades. So you are not sure whether the marks entered are right or wrong. So what do? Is you say marks entered %D marks, and you say you kind of control D here, GCC switch1.c./a.out 46. So you see, actually I should, let's keep /n here. So when there is a bug in the program, so in order to debug your program, people usually put multiple printf statements. Like for example, you want to make sure that the marks entered is the right, you are reading the marks right, so you print it. And you want to make sure whether the control is entering here or it is entering here. So what do you do? So again, you kind of put something like, you put a statement like this, printf entered here at no, grade A, something like that you keep. So these are debugging strategies which people use, wherein you enter, wherein you put multiple printf statements in your program to see how the control is flowing in your program. So this is a kind of rudimentary way, but sometimes it is useful, but many times you can just get away by not doing this using the GDB tool. Are you all with me in this class today? So I think we should conclude this lecture today. So what is the state of your mind? Are you happy for today's lecture? It's
So I have a doubt which is not related to today's lecture.
okay.
So just 1 second.
Yeah. Please go ahead.
So in the chat box, I've shared the link of a photograph, a screenshot I took while running a
Stop
program.
recording this and then maybe, okay, maybe let me record it. So I think the class is now over. Those of you who want to hang around and ask questions, you can be here. I don't have an issue. Yeah. So can you resend that?
Yes, sure.
Yes. Let me do one thing. I think it's better if I stop recording so that